So in this video, I want to talk about a question which concerns quantum systems that have many parts. So I've drawn an example where I have a collection of spins, and we've talked about how the general state of a system like that would be a linear combination of these basis elements that I can get by combining the basis elements of the individual systems. So I've written a general state here with some set of coefficients. If there are n spins, I'm going to have 2 to the n of these coefficients. And so that's a lot of information in general. Sometimes I might only be interested in the state of, say, the first spin in that system. And so that's going to be our question. How can we describe just the state of a part of a quantum system? So what is the state of the first spin? And if we had a state which is not entangled, then it's very easy to answer the question. So if we have a state where the first spin is not entangled with the rest of the system, that means that we can write the full state as a tensor product, or as a product of some state of the first spin, which in general would be written like that, and some other state of the rest of the system. And then it would be easy because the state of the first spin is clearly this state right there. But in a situation where we have entanglement, it's not so clear. And so we might think that there's also a state of this form. So when we have a single spin, we think the general state is going to be of this form. But and so what would we want to be true for that state? So what we would want is that if we think about our original state here, psi, which is the state of all the spins combined, well, we could imagine performing various measurements on the first spin in that combined state. So we could measure the spin component in the z direction, or the x direction, or the y direction. And so what we would want for the state, if we could describe the state of the first spin in this way, we would want to choose C1 and C2 so that all the measurements that we could perform on that spin in this state would match with the results of measurements that we would perform on the first spin in our original state. Okay. And it turns out that it is not possible. So it's not possible to find a state of this form so that the results of all measurements would match with the results in our original state. Okay, the results of measurements on the first spin in the original state. Okay, so if you have an entangled state, then it's actually not possible to describe the state of the first spin in this conventional way that we think that we describe the states of a single spin. There's actually some more general way that we need to think about states in order to accomplish that. So to finish this video, let me just prove to you, giving you a simple example where we have an entangled state where we can see that we're not going to be able to describe the first spin in this way here. And so what I want to do is consider this state of two spins where we have 1 over root 2 up cross down minus down cross up. And so this would be, for example, the state of the electron spin and the proton spin in the very lowest energy state of a hydrogen atom. One of the things about this state is that it is rotationally invariant. And so if I perform any rotation, then it leaves the state the same. Okay, and so in particular, that means that if I were to make any measurement on the first spin in this state of some spin component, so let's say I measure the Z component of spin, and I want to know what is the expectation value of that Z component of spin. Well, it's just going to be 0 because the state is rotationally invariant. And so there can't be more chance that I measure the Z component of spin being up or down, otherwise it wouldn't be rotational invariant. And similarly, any component of spin, so I could measure the spin in the X direction or the Y direction or the Z direction or any other direction, and the expectation value is always going to be 0. Okay, but no state of a single spin has that property, because if you have a single spin, then that's actually always an eigenstate of some spin operator in some direction. And so there would always be some spin operator whose expectation value would be h bar over 2. Okay, so for any let's say C1 up plus C2 down, there is some operator, some spin measurement we could do in some direction, so that psi Sn psi would be h bar over 2, or I should say psi 1. Okay, so in this is just one example of an entangled state where we could think about measuring the first spin in that entangled state in the larger system, and there's no state of a single spin whose measurements would match that. Okay, and so in the next video, in order to be able to describe what is the state of this first spin in an entangled state, I need to talk about the idea of an ensemble of quantum states that you might be familiar with from statistical mechanics.